Hello world, my name is Alexander. I work on Fluent UI React at Microsoft Development Center Prague. In the previous episode, my colleagues and I talked about positioning in Fluent UI React v9. In this episode, we will talk about how styling works, our journey with CSS, different approaches we took, and why we have our own CSS-in-JS engine called Grifo. CSS is a key part of web development that's used to style and lay out web pages. And it's required to style our React components for web. However, with CSS there are common problems that increase maintenance cost for large applications and libraries. And as a UI library, our goal is to simplify usage of components while reducing complexity and maintenance cost. Unfortunately, there is nothing built into CSS for easier maintenance and management of styles. At the same time, the approach that will be chosen for CSS management defines how performant, scalable, and maintainable components will be. And we have learned this from our past experience with previous versions of Fluent UI. Different approaches and technologies exist to solve CSS problems. We will cover differences between them a bit later. For now, let's talk about CSS specificity and why this is a problem that every application deals with. CSS specificity determines which CSS property values are the most relevant for an element, if there is a conflict. It's a hierarchy of different CSS selectors, which are ranked by increasing specificity. The common misconception is that order of appearance in a document is part of CSS specificity. But it's not. It's another criterion of cascade sorting order. We will not explain the entire topic in this video, but I recommend reading an article on AppDN that explains CSS specificity much better than I could. While Fluent UI React components are reusable, customers still need to apply some styling tweaks to them, and they should be able to do this. This brings us back to the importance of CSS specificity, because customer style overrides should be more specific than CSS rules in the library. Otherwise, their styles will not be properly applied, even if they are defined and present on the page. Normally, there are no issues with order of appearance. Modern bundlers handle most cases properly based on the order of imports, even inside JavaScript modules. However, there are still issues when the order of styles might change based on JavaScript module loading. A good example for this case is lazy loading. At the same time, applying styles based on the imports order is not a good idea, especially for large-scale applications that imports CSS from many modules. For example, during refactor, someone can simply move imports, and the application appearance will be broken. We have a slightly bigger problem when using CSS selectors. Let's take a moment to reference Semantic UI as an example. Semantic UI offers a nice concept for CSS definitions. They use semantic language. It's easy to write UI vertical menu and understand how it looks based on the HTML markup. Despite the fact that the concept is understandable, it leads to complex CSS selectors that create CSS specificity problems. On the snippet, you can see that the selector uses three classes. In order to override the margin, we should use a selector with at least three classes or more specific like IDs. You will not believe how many issues related to this problem exist in Semantic UI repository. This pattern leads to confusion and frustration for customers, because even for simple overrides, they need to know about CSS specificity in this specific case. The previous example is the simplest case, and at the same time, Semantic UI is full of similar problems. However, even without CSS frameworks, the same problem will appear sooner or later. Let's look at a case with a button. For now, we assume that the basic styles for a button in the library include some properties like margin, display, and padding. Perfect, we have our button And it works. Someday our design team decided that a button can also have primary state. Easy peasy. New CSS rule, and we are done. A week later, our design team realized that the button needs to have a circular shape variation. No problem, it's doable. Everyone is happy, our application is shipped to production. Another week later, our design team realized that the combination of primary state and circular shape should have different box shadows. Again, it's fixed. Okay, let's look at the snippet. It's growing and becoming more complex. Let's also compare it with what we discussed in semantic UI. Now imagine what happens once you receive a request to add disabled state. I'm getting déjà vu. What about you? Yeah, it's the same problem. In order to override the box shadow property for primary plus circular combo, customers will need to deal with the selector specificity. Unfortunately, in the reality it's even worse, because styles could come from multiple sources. Definitions from CSS files, inline definitions via style attribute, and the party king important. All this goes through specificity calculation, inheritance, and defaulting. This process might be straightforward for machines, but not for humans. We will talk about solving specificity issues a bit later. Now it's time to talk about ways to manage and structure CSS rules.
One of the problems is that CSS lacks built-in namespaces. It's one of the reasons why developers have issues scaling its usage. Historically, the global namespace was designed as a core feature of CSS to enable portability and cascading. This is the DNA of CSS. How can CSS meet the incompatible demands for simplicity from developers, flexibility from designers, and responsiveness from users? CSS can't by itself. It needs its help from more abstract high-level tools and techniques, such as CSS-in-JS or preprocessors, to make it closer to a programming language. Let's go through existing approaches and methodologies to check what problems they solve. Our first guest is BEM, or Block Element Modifier. The idea behind BEM is to divide the user interface into independent blocks. BEM is a set of rules for naming CSS classes, where everything is a single class and nothing is nested. It's recommended to avoid combined selectors, and as a design system, we can follow this rule. The most important thing about any approach is to ensure that developers will follow it. But can it be enforced in a giant corporation? Probably yes. Linters for CSS exist, there is a lot of rules for them, and we can always write our own. But it's too optimistic to say that all teams across the organization will follow the same approach. BEM naming convention allows to downgrade specificity of most selectors to 1. This approach reduces a rule priority management to just managing the order of appearance. But all similar approaches will come crashing down on rocks of the human factor. There is no guarantee that a developer from a team A won't use the same name as a team B. The naming problem can only be solved by assigning a random name to the CSS class. Meet our next guest, CSS modules. CSS modules are CSS files in which all class names and animation names are scoped locally by default. CSS modules perfectly solve the naming problem, since all classes are now random. Sounds like a solution for the global namespace problem, right? But do CSS modules actually solve the specificity problem? Unfortunately, no. CSS modules will hash classes to avoid collisions with the global namespace, but the specificity problem is still there. But what if we combine BEM and CSS modules? That's a quite common practice. Since class names are encapsulated to a module boundaries, there is no reason to use the base class like .button in selectors. In fact, we can just remove all .button class selectors in the example. That gets us back to managing just the rule order in most cases. The fair note is that this works for simple cases. For more complex ones, it does not, as selectors could be combined. Looks like a never-ending circle. This is where CSS-in-JS libraries enter the game to to offer solutions for specificity problems. Well, at least a few of them. Emotion is blazing fast and very close to plain CSS in terms of performance. So why cannot we use it? There are a few reasons. While its performance is great, it still does a significant amount of runtime work. It also outputs monolithic classes. For example, we have base component styles and style overrides. To merge them later, Emotion concatenates CSS inputs and generates a new class for the result. This work can only be done during runtime, why we would like to reduce runtime to 0 or near 0, especially considering that the trend of zero runtime CSS-in-JS started to grow in JavaScript community. Emotion also allows us to define styles inside React components. At a glance, there is nothing wrong with that. But once the input values change frequently, there will be a significant performance hit. There is nothing wrong with Emotion. The same is applicable to Fela and other libraries. It's how developers use the API, and no one said that it will always be optimal. Once style computations happen inside the component and rely on its state, a lot of runtime work is required for each render of any component. The opposite approach to monolithic classes is atomic CSS. In atomic CSS, every property value pair is written as a single CSS rule. Our next guest, Fela.js, relies on it. Specificity issues are solved since we cannot have duplicate properties in output and every definition has single class specificity. Nice and clean approach. Why don't we use Fela then? Well, we have used it in Fluent UI North Star, and honestly, the main problem we have had with this library has been its performance. The API design does not fit well into React component lifecycle, where everything renders frequently, and with every render, the styles are recomputed again and again. We added a caching layer to the library to achieve some reasonable numbers, but in terms of performance, it's still far from plain CSS, especially during the first render when styles are not cached. Both Office UI Fabric and Stardust UI use custom solutions for styling via CSS-in-JS. By the way, if you are confused by the naming, I suggest checking the first episode of Fluent UI Insights, which covers that. It's really confusing, even for us. From one perspective, it's bad that there were two styling solutions doing the same thing. From another perspective, it's good, because we learned different things, gained experience, and collected a lot of feedback from our partners. The funny thing is that in both libraries, we encountered the same problems. Each library had performance issues related to its styling layer. Once the convergence of the libraries started, we came to an interesting conclusion. We cannot make the existing solutions faster and closer to plain CSS because too much work was required at runtime.
Unfortunately, this episode is going to end on a bit of a cliffhanger. We covered common problems with CSS and the existing tools to solve them. In the next episode, I will talk in detail about our CSS-in-JS solution called Grifo. You will be able to learn some of the key implementation details and the context behind them. See you next time. There are no issues with JavaScript. That's true.
The opposite approach to atomic CSS is atomic CSS. You know, you are celebrating that you finally managed to pronounce specificity and fail to pronounce R.